Physical changes. Matter undergoes changes. Some of them are physical, some are chemical. In a physical change, we're just altering the state, physical state, solid, liquid, or gas. Or we may be modifying the appearance, but we're not actually changing the composition. So the atoms or molecules in that substance don't change. Here's a pot of water boiling on the stove. If we were able to zoom in and look at the individual molecules, they might look like this. So here's little water molecules. It's in a liquid. So they're close together, but they're moving around. As you heat this up, it goes into the gas state. In the gas state, the individual particles, the little Mickey Mouse heads, are the same, but now there's a lot of space in between them. Has there been a change? Yes. But it's a physical change because the individual molecules have stayed the same. If you take a piece of wood and you saw it in half, have you changed it? Well, you've changed how heavy each piece is, you've changed how long it is, you've changed what it looks like, but the individual particles that make up the wood are the same. Okay, so that's a physical change. In a chemical change, the individual particles are getting rearranged, recombined. An example of this is rusting. So here we have a nail, and we all know that iron rusts. So in the original iron nail, we have iron atoms, and they are arranged in this crystalline solid structure, and they're all just iron atoms. When iron reacts with oxygen, it forms iron oxide, which we call rust. And now we have oxygen atoms interspersed here between the iron atoms. No longer is this just iron atoms. It's now iron and oxygen. That's a difference in the particles. And we see differences in the characteristics as well. Rust has a different color. It's kind of a reddish color compared to the silvery color of nice shiny iron. Iron is strong. Rust is not strong. It's flaky. You'd never build a car out of rust because that's what your car turns into instead of. So we have the atoms rearranging. The atoms themselves retain their integrity. We still have the iron atoms. Nothing happened to them, but they're arranged differently. Okay? In this physical change, we see that the arrangement of the individual molecules is the same. They're just being separated from each other. So this is a chemical change. It alters the composition. More examples. This is a piece of dry ice. Dry ice is solid carbon dioxide. So we have carbon dioxide molecules, they're very close together, and they're fixed in relationship to each other. As this sublimes, which is the name for the change from a solid directly to a gas, the reason they call it dry ice is it doesn't melt. Regular ice could be called wet ice, right? Because you stick it in the cooler and as it warms up, it melts. Dry ice never melts. That's why it's dry ice. So it goes directly to the gas state. That is a state change. That's a physical change because here the molecules are the same. All that's changed is how close they are and what they're doing relative to each other. That makes sense? Sugar dissolving. You put a teaspoon of sugar in some water and stir it up, and something has changed, right? You used to have a solid and a liquid, now you have one liquid, and it tastes different. So here we have sugar molecules, and they're in the solid state, and now we're dissolving them in water. This is what the sugar molecules look like in the little sugar crystals. When we dissolve them in water, the sugar molecules haven't changed. They're just separating and swimming around in the water, but they are still sugar molecules. So this is a physical change because the particles didn't change. Okay? Propane gas, burning. You have a little propane burner. These are the propene, that's a thing too, but that's not what we're talking about. Propane molecules. And when those combine with oxygen from the air, and that needs a spark to get it started, there is a chemical reaction that occurs. And now we have carbon dioxide molecules and we have water molecules. And before we just had these propane molecules, which were C3H8, 3 carbons, 8 hydrogens. They react with the oxygen and become CO2 and H2O. The particles have changed. They're not the same anymore. The molecules are different. The individual atoms are still themselves, but they've made new associations. They're grouping up differently. That's a chemical change. Any questions? So, summary, physical property. We were talking about changes, now we're talking about properties. It's always confusing. So there are physical and chemical changes, and then there are physical and chemical properties. So a physical property is one that you can observe or demonstrate without changing the composition of the substance. So the smell of gasoline. You can smell the gasoline, but that doesn't change the individual particles. You can demonstrate the melting point of ice by melting an ice cube. That doesn't change the individual molecules. You can cut a piece of iron in half and demonstrate that it's hard. You can observe the color. You can measure the density. That doesn't change the substance. Doesn't change the particles. Those are physical properties. A chemical property can only be displayed by destroying what you're dealing with. So gasoline is flammable. That's a chemical property of gasoline. To demonstrate that property, you have to get some sort of a spark, and there needs to be oxygen, and when you demonstrate that flammability, you're destroying the gasoline. You're changing it into something else. It's a chemical property. So things like corrosiveness, acidity, toxicity, iron rusts. That's a chemical property. You demonstrate that, you're destroying the iron. So determine whether each change is physical or chemical, and then what kind of property, chemical or physical, is demonstrated in each case. So if we take a copper wire and we smash it with a hammer until it becomes flat, is that a chemical change or a physical change? It's a physical change. We've changed the shape of the copper wire, but it's still copper. The atoms are the same. So that would be a physical change. What kind of a property is demonstrated there? You can hammer a copper wire and flatten it. That's a physical property, because you can do that, you can demonstrate it or observe it without changing what the copper is. So that's a physical change and a physical property.